Hi guys, in this video we're going to look through lesson 6. So we're really going to talk about tangents, secants, and their lengths. So what I would like you to do here for this first exercise is find the following products. So we're given what PA and AC, PB and BD are. What I want you to do here is pause the video and multiply those pieces together and just see if you notice anything special about that in part B. When you're done multiplying and get all your answers, then go ahead and unpause the video. You should have had your products get 10, 24, 40, 8, 24, and 12. Now there's two of them that get a pair of the equal amounts. So we're looking at these ones here. So let's think about how we would describe that. So we want to figure out a rule to find the lengths of the parts in these circles here, especially these secants. I know they're secants, remember, because look how many times they touch my circle. So in that line, it touches twice. And in this line, it also touches twice. So we're talking about the pieces that are a line segment that intersect our circle twice. So it's like, if I'm looking at it, on the first one, it's the 3 is the outside piece, and the 8 is the whole thing. And same thing here, 4 is the outside piece, and 6 is the whole thing. So if I were to describe this, I would say we would take the outer times the whole thing of one secant, and it's equal to the outer times the whole. And I like to think of that as ow, ow, because some of you like to think that math is painful, but whatever helps us remember it. So ow, ow. Again, lucky for you guys this year, the one nice thing for doing this is that you don't have to memorize as much. So you don't have to worry about having this memorized for a Regents exam, just to understand where it comes from. So on my next slide here, that's exactly what the rule is though. If two secants are drawn from a common exterior point, then the product of the length of one segment, secant, with the length of its external piece, so the whole thing and the outside piece, is equal to the product of the length of the other secant, with the length of its external piece. So it's, again, outer times whole. And you'll see Scooby and Shaggy going in for the fist pump there now that we've got a new rule. So let's actually try that here. In the diagram of circle O, we are given AB is 6, BD is 2, AC is 4, and we're going to try to find the length of CE. Now, in this case, when I'm looking, remember, the whole thing here is 8. So when I go to do this, when I go to use my phrase, ow, ow, the outside piece of the first one is 6. The whole thing is 8. Now that's equal to the outside piece of 4. And let's say I just called this whole thing x for a second. So the whole that I don't have is x. So when I multiply, I'm looking at 48 equal to 4x. I'll divide both sides by 4. 12 equals x. So remember, that whole thing is 12. Be careful, because we're not looking for that in this case. We're looking for CE, this piece. So to finish this off, CE is equal to the whole thing. Subtract the outside piece. So CE is equal to 8. Okay. Now we're given the next rule of secant and tangents together. So that rule only worked if you have two secants, two lines that each touch the circle twice. Now the maximum a line can ever touch a circle is twice, because you can't wrap around and make your way back through the circle for a third intersection. That just wouldn't work. Okay. But we've also seen tangents that touch a circle once. And we could end up with a situation where a line and a circle just never intersect. So the only possible scenarios are 0, 1, or 2 intersections. So if we have a secant and a tangent that are drawn from a common exterior point, then the product of the length of the secant with the length of its external segment is equal to the square of the length of the tangent. So basically, it's still outer times whole, because it's still the secant, but look at a tangent. The tangent is the outside piece and it's the whole thing. So instead of doing outer times whole, you're taking the tangent and you're multiplying it by itself, which is known as squaring it. Okay, and you have the girls Daphne and Velma looking into their textbook there. So let's actually try that exercise 3. So we have circle O. Now we have a secant ADC, so notice it touches twice. They always have to give you the order of the segment ADC. It's a length of 12 units. And it's telling us that AD to DC is in a 1:3 ratio. Then determine the length of AB. So there's a couple parts in this one first. So we're going to use this ratio piece. Remember, it's telling you that AD is 1 and DC is 3 times the size of that. So what you could do is kind of slap on X here. 1X and 3X. And so those two pieces together add up to 12. So we have 1X plus 3X equals 12. So I'm looking at 4 pieces all together. So X by itself is 3. Okay, so that means AD is a length of 3. And 3 times X, 3 times 3 is a length of 9. So now we have those pieces. With that being said, we can go in and find that last part of AB. And just to not have any confusion, I'm just going to call it Y in this case. So remember, the new one is having tangent squared and that's equal to the outer times the whole. So tangent in this case, we're going to call it Y, so Y squared equals the outer piece was 3, the whole thing was 12. So we end up with Y squared equals 36. Take the square root of both sides. Y is equal to 6. So the length of AB, which is what we were trying to find, is equal to 6 in this case. Okay, one final question for us here. Exercise 4, in circle O, secants have been drawn from the external point of P. We will prove that PA times PC is equal to PB times PD. But first, we have to explain why angle C is congruent to angle D. So I want you to see angle C. When I draw that in, notice how it's formed. C is the vertex, okay? It opens up to this arc A to B. Now I also have angle D, which starts here. So I'm looking at the vertex that it opens up to, and it's open up to this same arc AB. Well, both C and D are known as inscribed angles, okay? So that's the first thing we have to mention. Both angle C and angle D are inscribed angles. And look carefully, their arcs they have the same intersected arcs. So they open okay. So if they both, think about that rule. It's been a while since we talked about the inscribed angle rule, but the angle is always half of the arc it opens to. No matter what that arc length is, if they open up to the same arc, they're going to both be half that arc, so their two of them are congruent. Okay, so that being said, we have those two angles which we already know are congruent. So there's one angle. Now notice that here is the first triangle, and here is our second triangle. they both have one very important piece in common. They both have angle P. So angle P is congruent to angle P. Remember, that's our reflexive property. So triangle PBC, oops, not congruent, is similar to triangle PAD by angle. Two angles is enough to show that we're okay there. Don't say anything about right angles. Even if B and A start to look like one, we don't have that for sure, so we can't use it. We do know the angles are going to be congruent. We just don't really have a valid reason to explain it right now. We could, all we need is two angles though. We would have to go into explaining why the third angle would work. Now, since my two triangles are similar, we can set up the proportion. Remember how this part works. So, if I were to set up my proportion, I would start with PA, right? So PA is this piece here. And we could go in and say that it would correspond to PB. Now it's equal to, let's say, we'll take this side PD over this side of PC, right? And that would be because of corresponding sides in similar triangles are proportional. And then when we cross multiply, PA times PC is equal to P times PD, because the product of the means is equal to the product of the extremes. So we'd be able to show that proportion. So that works every time, which in our case shows us that the pieces of the secants that we wanted to show, PA times PC. So if I erase all this stuff on here and show you why it was so important to prove that, look what we just did. PA is the outer, PB is the outer, times the whole thing of PC and the whole thing of PD. So I just proved to us why we can always use that as our secant rule. We also know that if it was a tangent and a secant, it's tangent squared because the tangent's outside and it's the whole thing. Now remember, the only reason why we don't have a tangent rule on here is because we've already talked about that. If you have two tangents to the same outside point, they're always equal to each other. Okay? And for my last slide, just keep in mind this very important date coming up for me, that May 15th, Scoob is available for you guys to watch at home because it was going to be in theaters, but they decided to make it available on different networks online. So you don't have to watch it, but I know I will be because I love Scooby-Doo. So hopefully some of you guys watch it too, and we can discuss that next week. But there'll be some fun Scooby-Doo trivia up that you can do as well, but it's all optional. Anything Scooby-Doo related, I'm not forcing anyone to do. All right, guys, thanks for watching.